I think we shall have to make a real search for the neutron. The study of the radioactive elements is in some respects far more important than the study of the ordinary stable element, for the phenomena observed lead at once to the necessity of an atomic structure of matter and supply convincing proof of the individual existence of atoms. A substance that has the ability to spontaneously produce radiation strong enough to penetrate opaque materials like metal sheets and other materials that block light is said to be radioactive. As a result, the radioactive processes show that atoms contain a vast amount of energy, due to the fact that the chemical and physical forces we have available to us were insufficient to break atoms down into simpler forms. No signs of this had previously been seen. As can be seen, research on radioactivity has directly demonstrated the atom's place as a basic building block in the construction of matter, because they deal with the disruption of the atom. Radioactive changes are very distinct from regular chemical changes, which deal with the dissociation of molecules into atoms and the ways in which atoms combine. Physical and chemical agents have no influence whatsoever on the radioactive processes, which are spontaneous and unpredictable. However, the work was more of a consolidation than a discovery. Despite numerous attempts, the roads to other sectors could not be discovered. Nevertheless, there was a lot of intriguing and significant work done. It was so challenging to learn anything truly significant that Rutherford was a bit let down. If the Compton recoil that caused the proton to be ejected from its quantum of 52 × 106 electron volts is what caused it to be ejected, then the nitrogen recoil atom that results from a process similar to this should have an energy of no more than about 400,000 volts, produce no more than about 10,000 ions, and have a range in the atmosphere at NTP of no more than about 1 to 3 millimeters. In reality, at least 30,000 ions are created by certain nitrogen rebound atoms. I worked with Dr. Feather to see the recoil atoms in an expansion chamber, and I calculated their range visually to be as much as 3 millimeters at NTP. On the assumption that the radiation from beryllium is a quantum radiation, if energy and momentum are to be conserved in the collision. It is exceedingly challenging to explain these results as well as others I have got throughout the course of the research. But if it is supposed that the radiation is made up of neutrons, which are particles with a mass of 1 and a charge of 0, the problems go away. Possible hypotheses include the production of a C12 nucleus and the emission of a neutron as a result of the B9 nucleus capturing the A particle. The neutron's forward motion may likely be traveling at a speed of roughly 3 × 109 centimeters per second based on the energy relations of this process. The observed recoil atom energies are in reasonable agreement with the theory that the recoil atoms are produced as a result of this neutron's collisions with the atoms it passes through. Furthermore, I've seen that protons ejected from hydrogen by radiation that is emitted in the opposite direction from the A particle that is stimulating them seem to have a significantly lesser range than those ejected by the forward radiation. Since the atom is neutral overall, there must be a positive charge attached to it that is equivalent to the sum of its negative charges. The equilibrium of the atom is maintained by the electrical forces existing between the positive and negative charges.